concat in alpha. Okay, concat in alpha has also been requested. Sure, so we'll likely have time to go over both of these. Oops. Zoom's copy and paste is sometimes different than your computer's copy and paste. So due this Friday is your coding bat problem set related to the palindrome checker. Your palindrome checker assignment, either done in Replit or in processing and uploading it to GitHub. And lastly, you have your weekly reflections as normal. A couple of you marks absent the other day because you didn't start your reflections. If you care, go ahead and email me to update it. Or if you don't, then just leave it be. So today's topic is how we deal with capitalization, spaces, and punctuation marks. So far, you should have gotten how to reverse a string in CodingBat, and now we'll address like nurses run, and madam I'm Adam, and a man, a plan, a canal in Panama. So these later couple palindromes with spaces and punctuation marks, let's go through how to parse it. Compare to and index of. So these are more string functions that will be useful for you. Compare to and index of. So from the quick reference guide, the little cheat sheet you're given during the AP test, looks like this. We'll talk about index of first, because I think that's more intuitive. Returns the index of the first occurrence of str, of whatever you enter, and returns -1 if not found. So you zoom in and look, okay, we got strings being called apple and banana. Banana happens twice. In string 2, which is banana, where is the first n? And you see that the first n is in position 2. 0, 1, 2. Yep. Index of n. And then here, the quick reference guide should show you this, but this 3 is starting at position 3. Where is the first n that you see? So in this case, 0, 1, 2, 3. After this point, the first n that we see is in position 4. String 2, index of x. X is not contained in the word banana, so -1 is returned, not found. Pretty straightforward. Compare to, though, a little bit less straightforward. So as we read its description, int compare to string other. The input is called other. Returns a value if less than 0 if this is less than other. Returns 0 if this is equal to other, and returns a value greater than 0 if this is greater than other. Okay, so what does that mean? As we compare string 1 and string 2, okay, this will take the place of string 1. We're comparing string 1 to string 2, apple and banana. Apple comes before banana alphabetically, so you see that a -1 is produced, and that's what it means to be less than. String 3 compared to string 2. Question, Justin? Okay, maybe your mic was accidentally turned on. Okay, so string 3 compared to string 2, they are both the string banana, so 0 is returned. And we should see an example with the third one, but that is not here. I don't know if the slides review it, but the coding batch certainly does. When you use compare to, it compares the whole string's value. So think about it as the function you would use to make things alphabetical. It doesn't check just one letter at a time, it evaluates the entire string that's there. Here's some more string stuff that will be useful. This stuff was not on your AP exam versus these couple, index of and compare to, are expected for you to know on the AP exam. These ones aren't, but for the purposes of our palindrome checker, these 4 functions will be very useful. So let's first talk about contains. What do you think the output of this little code segment will be? What will be produced? Go ahead and type it in the chat. Very good. Contains. You had a feeling it would ask a question. So then you see, almost. So here's the answer. True. You're asking yourself the question, does the word hello contain the word hell? True, meaning yes, it does. So take a look at this example. Go ahead and type out what you would see on the screen. We are now looking at equals ignore case to uppercase. Those functions should be rather intuitive. Okay, we'll let some more answers trickle in. Nice. So let's go over the outputs. If you typed out this one, ignore that last line. I don't know why these two slides were slightly different, but the main words you should see is equals IC, abbreviated for ignore case, and all capitals the word hello. So in the first one, S1 compared to S2, this compares the values of these two strings. They are not the same. Hello, all lowercase, and this hello with jumbling uppercase and lowercase. So this if statement, or this little chunk, right? S1 dot equals S2 returns false. So you don't print equals all lowercase. As imagined, equals ignore case ignores the uppercase and lowercase of the letters. This is therefore true. That's why you see equals IC. The final print that is not within an if statement, S1 to uppercase. This makes all the letters in S1, which was lowercase, all uppercase, and that is what you print. This returns a string, but in the uppercase version. Pretty straightforward, I think. We talk about all four functions. Yes, so these are the four that will be useful for your palindrome checker. On the AP test, it gets a little bit tricky. So you can use this code, but it's more like a double-edged sword, because if you get it right and it works, the grader has to give you the points. But if you get it wrong, you get penalized more because you used functions that were not on the subset of Java, like on the quick reference guide, or that the AP test expected you to know. The reasoning behind that is the AP computer science exams, at least the FRQs, a lot of AP exams, it's still hand graded. People have to read through your code, and if you use functions outside of what they expect you to use, it takes them more time. to check it over, and that's why their grading is the way that it is. So like contains, right, like it is super useful. And we'll go over it like when the AP exams come closer, these little nuances and stuff. Like when you practice it more, it's not so bad. Okay, second idea, static functions or methods. So static methods can be called with the name of the class rather than the name of the instance of the class. You've used static functions before. Way in the beginning of the year, you used math.random with dice, with lightning. Then earlier this semester, you did double.parseDouble for the Google Billboard assignment. Notice that math and double are both names of the classes. However, there are non-static functions, and you've used one of these before too. So for strings, substring is a non-static function. Notice that here we can't do string.substring 1 through 4. The input always changes, so in this case, A here, because A changes, it's non-static. Your input string will change. Substring will have different behaviors based on like the numbers that you input it, versus like random and parseDouble. These ones have like a set behavior. It isn't input dependent. And that's why it's called static versus non-static. So here's an example. Notice here we have a static function that returns a string inside some class. So the usual call to this would be to make an object of type SumClass. Here we call it Bob. And to use sum function, we do bob.sumFunction. Okay, this is if it were non-static. This is the way we're used to, because we'd never used the static keyword. But if you choose to, by introducing that static keyword, you can now refer to it as SumClass.sumFunction, with the name of the class there. Is this useful? I don't really think so. It's more like when you're reading up on new functions to use, if it's static, then it works in this way. You use the name of the class and then the function name. Static will be on the AP exam. I'm not sure in what manner, but you should be aware of what it means. Static allows you to use the name of the class, then the function. And in terms of practical programming, like I don't know, I'm pretty sure I never had to use the word static before. Usually it was in code that was given to me where like the professor had a set behavior on this function and made it static so I don't change it or something like that. In like when you use these like very useful math functions, these are static functions. Absolute value, power, square root, random. So these are all borrowed from the math library. You would do math.abs for absolute value, math.square root, math.random. You can't just do abs, for example. So this stuff you can expect to see on the AP exam. You might be forced to use it on your FRQs. Okay, but really all that motivation is for this thing, for your palindrome checker assignment. Character, the name of the class, or name of the class, or characters, right? The primitive, or the would have been primitive. Okay, we're going to borrow the isLetter function. And as you expected, isLetter checks to see a certain see is if a string that it's given is a character or not. So it's not a digit, it's not a number, it's not a space or a punctuation mark. So letter of the alphabet. Notice here, string character at, Position 2, 0, 1, 2. The letter B, is that a letter? Yes. It returns true, so you print the word 1. If you check at character at position 3, is it a letter? 0, 1, 2, 3. 2. 2 is not a letter, so you shouldn't see the word 2 printed. Ta-da. So take a moment to stare at that and process it. So again, in plain English, right? You're asking the computer, is the character at position 2 a letter? Is the character at position 3 a letter? Alright, moving on. So, you may be at the point where nurse's run is the next palindrome you're working on. It should be counted as a palindrome, but in this program that's unfinished, it doesn't. One way to go about addressing this test case is finishing up only letters in the coding bat problem set. And here's a short example of using only letters to kind of take out the spaces and then do the reversing and comparison so that you get the correct output. Okay, this slide would be very useful for those that are kind of stuck on the later couple test cases. Notice string word2 is created to store the only letters version of the word word. Then word2 is compared to the reverse of word2, not the original word. No spaces. Let's go ahead and talk about that, if there are no questions on what I went over in the slides. In summary, we went over a handful of useful non-static and static functions related to strings. Okay, and if you like, you can use most of them in your coding that problem set. Okay, so no spaces and concat and alpha. No spaces. Let's do that one first. Zoom in a little bit. Oops. So just to see that my coding bat's working, I'm just going to return the word hello. I know it's wrong, but I wanted to see the outputs. Okay, there's 4 test cases. Returns a new string that is a duplicate of the argument s word with no spaces. All right. First we must, what must we do? There should be something useful. Where's that thing that ignores cases, right? This one ignores cases. This one ignores uppercases. We only care about letters. So, let me think. So out of these new functions, let's see if we can think about it like find the space that's there and then remove it. So we have to check to see if equals contains, not so much. Yeah, index of seems particularly useful, right? We want to find a space. Where is the space located in my string? Then from there, you can like do some substring stuff, like from the beginning up until until you see the space, like that's your first substring. Then you can continue marching, like from that space, look on, going if it's a long sentence, go on to like the next bunch, find the next space. When you do find it, take that substring, and so on and so forth. Okay, so index of should be super useful. So that would look like a number is returned, right? And then that gets kind of tricky. So I'm pretty sure we're going to use a for loop. Let's just try to find the space in hello world first. So we'll do sword dot index of the space character. Double check the time. Okay, got like 9 minutes, like that. And so this should return. I want to see it, that's why I'm returning it and adding the empty string to it so I see those numbers, right? So in this case, hello world with a space in it has a space at position 5. 0, 1, 2, 3, 4, 5. Nice. And now, using this information, notice this is the part we care about, that number. This contains the index of the first space. We're going to use that in a substring function. sword dot substring. In this case, just looking at the test case hello world, we start at position 0, go up to position 5, like that. We should have isolated the word hello. Here we isolated the first x. Here we isolated a. And in this case, we have went out of bounds. I think we can address that. When we see the empty string, go ahead and check if my string is empty, so it equals 0, then you return like the empty string. So then I can knock that test case out, the edge case. Then we go back to here, okay? So if I were to hard code in what was in hello world, we have to ignore, well, we have to get back the word world. So then we have to add beginning, like all this stuff again, beginning at position of the first space all the way to the end. So the one argument version will serve us well there. Oops, sorry. What did I delete? Here, like that. Did it take something else? Is there actually a space there? Oh, it's inclusive, so we have to do +1. There we go. So we got that second test case. I notice now it worked for, it didn't, did it work for this one? 1, 2, 3, yeah, it worked for the second X here. It didn't work for the B here. See that? And now, like within this thing, yeah, there is some repeating we can do for these later couple strings to was it for int I equals 0. Wait, hold on. So this is me going through it. It may not be the most efficient. You can find likely a better way to do this. This is my first attempt at trying to get to the answer. sword.length. So we want to go through the entire string. That might not be necessary now that I think about it. Yeah, we can do some tricky stuff. Let me continue with the idea I currently have. Something like this. Okay, we're going to need a string that will contain our answer. String ans equals empty string for the moment. And then down here we returned ans. Now this loop inside here will do answer equals answer plus something. inclusive of this one, stop here. So then this will be, yeah, maybe we don't need an I. Because like here, it's gonna go ahead and march through each character, which is doing a little too much work for us. Like if I press run right now, yeah, we get a bunch of out of bounds because you keep checking beyond its length. So maybe it's like a while loop would be more suited for us, not a for loop. While this thing, s-word index of, actually, sorry. I think, yeah. Alright. I'm gonna draw a blank. Some kind of loop. Maybe a while loop won't be the best. Alright, so this is where, as far as I got for now, with no spaces. And then this stuff here is likely to be replaced. I'm thinking here, oh, now you see why the second argument was mentioned. Maybe we do introduce that like I variable here for int I equals 0, I less than s-word dot length. Right, like this, the second argument index of tells the computer from this point, please continue checking to see if there is another repeat of the character. About 3 minutes. But then, like, I'm pretty sure I don't want to use the I character here. Because, like, in the X case, does this work? Alright, let me just go ahead and try some things. It may not make much sense. So let's do s-word dot index of space, comma, like x, int x. Where should it start? It should start at the first index of space. Yeah, maybe. Like the way I'm thinking about it, maybe index of is not the way to go. So yeah. I should have just done, so students are suggesting to me now, like, why don't you just go ahead and process each character by character, the words in the string, and use a for loop or use an if statement. That may end up being easier. But yeah, sorry. So this idea, perhaps I'll comment and pursue later. Like now is the appropriate point to say, like, I really don't like strings. So something like this, right? For int I equals 0, I less than s-word dot length, I plus plus. So in this stuff, should have just stuck with like this from the very beginning, okay? We're going through each character of the string one character at a time. If it doesn't equal a space, then we add it to our answer. So we still need this guy, like this. And once we get through it, we ignore the spaces. Oh, good job. I overcomplicated things way too much. Sorry, I wanted to use one of the new string functions. So we only went through no spaces. Starry student that went over was it concaten alpha? I think yesterday's block 6 videos goes over concaten alpha. That does use compare to one of the new functions and can be solved in one line. So block 1, you're dismissed. Yeah, I'll get it working. See you later. Have a good Wednesday.